So Montessori Math is probably the most visible of Montessori materials. A lot of what was created for Montessori has actually been adapted into more traditional education. So that's fun to see. And it also really changes the way you think about the process of math. So your children may come home explaining something to you and not be focusing on the same thing that you would. So we don't actually focus a lot on the answer when they're younger. We are more interested in the process. So somebody something that I saw just the other day is they had a bundle of 10 bars in their hand. They dropped one. They had counted that one already. They counted what was in their hand and then saw the one they dropped and added one more. So they had 8, but they counted that one twice and they were like, oh, it's 9, which is fine because what they were learning was adding. So we do want them to get the right answer, but we want them to understand the process more. Let me actually get to the slide of that. So Montessori Math, if you think about it, it is a spiral. You learn something at one level. So in primary, you're seeing some of the same materials that you'll see, and you're practicing some of the same concepts, but you'll keep practicing them later and later. So it moves up in a spiral. It's mastery based. We don't say on Tuesday we're doing addition, and the following Monday we'll move to subtraction. It's, oh, hey, you look ready for addition. Let's do this. Isn't it so exciting? Practice it. And when we see that they're ready to move on, we'll move on to the next step. Math moves from simple to complex. So you are adding without exchanges, what we call a static problem. And then you'll add with exchanges. So 6 plus 7 is more complex than 3 plus 3 because you have to move into a different place value. And we use manipulatives to understand both meaning and process. Every year there are adults who are like, oh, that's why you flip the number when you divide fractions. There's a real reason, but we just memorized it. So it's exciting to see that understanding. We have about a half an hour of videos because it's much more exciting than me talking about this. So for each one, I'm going to tell you about the material and then let you watch the video, and we can do questions afterwards. And the first one we're looking at is the spindle box. It really is about counting. Until the spindle box, students have not been introduced to the concept of zero. So this introduces the concept of zero, and it demonstrates numbers relative to each other. So one spindle takes up much less room in your hand than 9 spindles. Okay, this is risk.
And then the rest is for 9. Right? Let me count it. 1, 2. Yep, it's 9. Okay, let's put it away. From 1. 0, 1, 2. Oh, no, girl. Just take it out. Take it out. Nope. Take it out. Take it out. Take it out.
So you can see they give each other lessons, not always the way we would, but you see the 0 box has nothing in it. That's a point of interest as they're doing them, and how many, those 9 spindles barely fit in a hand. Oops, I didn't mean to we have plenty to do without me replaying them. But it doesn't want to move. Sorry, let me scoot on and share. Okay, addition with the bank game. The bank game is place value game and place value work, call it game. And it shows one little golden bead. We also sometimes call it the golden bead work. One golden bead is 1. And then we have 10 in a rod together. That's a 10. 10 of those is 100, makes a square. And 10 of those makes 1,000, and it's a cube. So you can really see and feel the difference between 1 and 1,000. It's not just where it is on the page. When you add, they actually join the numbers together, so it visually demonstrates computation. Same thing for, you can do subtraction, multiplication, and division with this. In this first part, here's order. And they set out all those cards. And they've been given a problem that they're getting the materials she needs. Nika has gotten
It's an apple with no name.
so it's
When you're gonna take a video of me.
he was learning. Winning their number.
6, 7, 8.
They're actually going to take the picture because it represents the number gets and subtracting, you do the opposite.
Five, 989.
So with the math, you can see how much they're practicing place value. They're practicing actually adding, building the number, and they are practicing, they're going to do a lot of movement, but they're also practicing saying the number. You heard them at the end, 5,989. That 80 is tricky. It's not just an 8. So lots of fun things to practice. Another material that moves is in primary and in lower elementary. It moves is the addition strip board. It's a way of practicing math facts and actually seeing what's happening rather than just memorizing them. Usually the blue one represents the first number that he's starting with, and then the red is what he's adding to it. The addition stamp game is in the primary classroom. It is used almost every day by different students in the lower elementary classroom, but some things continue to be the same. If you noticed that when they set up for the bank game, the numbers were color coded, they stay the same all the way through. Units are always green, tens are always blue, and hundreds are always red for every family. So it's the same for the simple family, units, tens, hundreds, as it is for the millions family or the quadrillions family. You can make as large a number as you like using these 3 same colors, just different families. In the stamp game, it becomes more abstract as things are moving towards more complexity because all of the pieces are the same size. In the bank game, they were different sizes. So it was really easy to see this is a thousands, it's a large cube. Here, it's the same size as the units. He has a board set it up to help him keep track of the order. That's something that some students use in class.
Okay, hold on. Let's go back to 8 times 5 because you can talk about it.
So he's building his first number, 1,454, it looks like. And then on the bottom, he's building.
I want to see you finish these 2 boxes today. I know that you can finish those 2 boxes today. The first one right here is crust. Yeah, I know you can finish those 2 boxes.
One of the reasons we do all of the finger work in primary is continue practice getting it. You can see that he's joining his number down and then how many units he has.
So you can go through and do 8 times 9 and 8 times 10 just to round out this and then
He has to exchange his tens because he had 10 of them. And he has to exchange his hundreds because he has 10. The great thing about manipulatives is you can see the spaces where there are zeros rather than just something down there or forgetting the zeros, which happens a lot as people are learning to write numbers. When I'm showing videos, I can't see your hand, so call out if you have any questions. We're going even more abstract. The small bead frame, instead of those squares with numbers on. I don't know if you could see that those numbers had a 1 or a 10, 100 or 1,000. Now you just have colored beads on a wire. Looks like an abacus. It's based on an abacus. The control of error is what we call it, like what helps you be able to make it work, is there are only 10 beads on each wire. So if you use them all, you have to do an exchange when you need more. Marin's going to do an addition problem really fast, but watch for her exchanges. She's building the number first. She's building it on her right. You can see when she gets to 10, she does an exchange and keeps counting.
Where does it go?
The multiplication beadboard, once again, these are all materials that students may be using in primary. They're also probably using in lower elementary. So these are some of our materials that really help students move up when they're transitioning, because they've already seen a big chunk of these materials and had lessons on them. And here they're refining. In lower elementary, they're refining a little bit. Will be a lower elementary student. It's really just helping them do multiplication using beads, seeing it laid out. It demonstrates, in this case, I think 4 taken 3 times or 3 taken 4 times. It shows the problem because you actually lay out that number of beads, that number of times.
So this is what it looks like. And there are numbers right here going up to 1 to 10. And you pick a number on here, which are scheduled number 1 to 10, and you pick a little card like this. I'm going to do 4 times 3. So then you take some beads and you put them up, so you put the one out. And so we do this. 1, 2, 3, 4, 5, 6, until we go down to 3 rows. I'm gonna do that, I think. So here we go. This is how you do 4 times 3. You go 4 out and 3 down. So however many beads you use, you count them, and then however many beads you use, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 is my answer. Thank you.
So you can see how instead of just memorizing with the addition strip board and the multiplication bead board, there's a similar division one. You're practicing those problems that would be memorized, but you're able to see visually why that's the answer. And that's what we're always trying for, is to understand why. The checkerboard is definitely an elementary work. It's for multiplication, and we use it for multiplication, 2-digit up to 4-digit multiplication. It really explains why we use the magic 0. If you learn to just put a 0 there and move over, this shows the reason. So for the reason, you can see if you're multiplying by 10s, you start with 10s. So in the beginning, we use another one to say, oh, 1 would be here, but we don't have that. That's your second partial product. We're just doing a single product here, though. So she's putting down the bead bars that show, like, that's 4 beads, 4 bead bars she has. So she's putting 2 of them in each one, in each square. And even if she doesn't know her multiplication facts yet, she can count the beads. little hesitation. What's the order? Figuring that out.
Want to tell me who's the answer? Or 5,000,000. See 687. 80. 7. Remember to say the name at the end. So 87 what? Good. Million. 687. And then you say the name after the units, so 87,000. Mhm. Got it. Thank you.
Little mini lesson there. Reading the number is a big challenge and something that we work on because you saw she's working in millions. And she needs to practice reading millions for her paycheck later. So I have to escape. This is the challenging part. It's another checkerboard lesson, and she's doing this a little more advanced. She already knows her multiplication facts, so she's actually doing it right along. You can see a more practiced view of it.
What's your one? Your units. The tens digit is
I'm gonna do one that I think you'll get wrong. You better get it right. In the next one.
You can see where there's 0 there. Similar thing as as we saw with the stamp game. There's actually an empty space where there's a 0. So that lets her know I write a 0 there. We keep going up in complexity. We're coming back to the stamp game, which we saw with addition. Stamp game gets used for everything in math. And in this case, she's doing multiplication with a double-digit multiplier. So you'll see partial products and exchanges. And with the exchanges, if you remember before, they're actually taking 10, putting it away, and getting the next place value out. So taking 10 units, putting them away, and getting a 10 out.
Add it all up.
So in this case, she had already did the first partial product, multiplying by unit. Now she's multiplying by tens. She's doing the second partial product.
Okay, so now I have to add the tens and the tens. Nine. Okay. Then okay.
Those little circles on the front show you that the multipliers. So that's 2 rows of 4 rows of units.
How did I not notice that? This is 5 times. Okay, well I have no 10. That means I have 100. Really? 48,102.
So you saw that she caught her mistake with the tens. That's part of what the material lets them do, is catch their own mistakes and learn from it and go on. And nobody is worried while she's doing the problem that she still had 10 there, because she would figure it out, or we would say, hey, do you notice this? We also, of course, teach fractions as part of math, part of geometry. And so our fraction insets lets them see movement and compare fractions, which is what you're going to see. And it connects to metal inset work that they were doing actually in the language area in primary and lower elementary. In upper elementary, it connects to degree measurement. They can take them, and we have a little measurement tool that they can use to measure how many degrees the 1/3 is, or how many degrees are 2/3. And a similar tool also round that they fit, that the pieces fit in, lets them see percentages. So you can actually visualize that 1/2 is 50%, because you can put it in the circle. Right now, they're just comparing in this video.
Yeah. Because basically,
You see them trying where the pieces don't work out. That's our control of error. You can't use eighths to make a third. It doesn't fit. So that's part of how they actually see that it just doesn't work. They learn to understand that concept rather than just memorizing what goes into what. And our last one, racks and tubes. This is definitely more of an elementary work. It has a horrible name. Sounds like a torture device, but it's very exciting to use. You can use 4-digit divisors in this. So you can divide a number in the millions by thousands, which is very exciting. Students love to work with big numbers. And from our perspective as educators, it just gives them lots of opportunities to practice because they're doing the same thing over and over again. So working with a number in the millions is just practicing 7 times. It also demonstrates the steps of long division, even though we don't ask them to write it down at first. So somebody was telling me that would have made it so much easier than just blindly writing down. I just believe it because I was a Montessori child. This is how I learned. So I can't go back and see it, but Jacob is going to lead you through.
Gray, well, let me go around. So white and green is 1. Blue, white and blue is 10s. White and red is 100s. Gray is 1,000s. Gray is 10,000s. Yada yada yada. And then after you have 100,000, you get to no. So we are going to start off. We have 3,169. We would build our number, and we have 3,000. So we would put in. Oh no. All you get on short lines. 1, 2, 3. Each of these is 1 fact. Make sure you do the proper color. And we have 100. So you would put in 1 lead from the hundreds part. Each of these has 10 in it, so you can do that to make it faster. And we have 10. And you have 9 ones, meaning perfect.
Supposed to do is you're supposed to line them up all the way to 4.
But for this purpose, I'm just going to put it on 4. Hope you remember. So we would start out with our thousands. And we would line them up. Since we couldn't make it to 4, we would not put a 1 there. We would put a 0. Well, 3. Since we have 3 extra, one of them no clip out of it. So let's pretend it's there. We had 3 extra, and so we would put 3, and you know that it takes 10 to make 1,000. Okay, I managed to do that. So we would put in 3, 2, since we had 3. We'll get back to finding the new speed later. So we would put a 0. Now we would take 10 as more. And we we would not go past 4, so we're going to go to the next row. This will take a while. So you see, we made 4, 1, 2, 3, 4, 5, 7 times. We did not make 8 because there was missing. So we would take these 3 extras. Put it back in there. And since we had 3 extras, we would put in 3, 2. Hopefully it has a remainder. And cleaning up.
Did you record?
And since we had 7 rows, we would put 7. At the very end, I'll teach you remainders. But now, numbers. See, we have 2 extra. Just imagine we're at 1s. There wouldn't be anything to do that, so we would write R for remainder, and then we write the amount that's left. 2.
So you can see in all of them how organized, I'm trying to escape them, how organized you learn to be for math, and how many steps there are. And they obviously, things get more complex as they move along in age, but they get to have all of this practice and do big problems on using materials. Oh, thanks, Heather. Okay, 2 questions. One, you heard me refer to multiplication. Oh, wait, I lost it. To multiplication facts. Is there a moment when students memorize the times tables? Yes, in that they sometimes do, like the multiplication beadboard, they do all the 4s. 4 times 1, 4 times 2. They'll write them out in using the multiplication beadboard as part of memorization. The checkerboard is often when students really start to memorize because they want to do it faster. And so they're like, oh, I need to learn these facts to be able to do it faster. So it's not so much this year, everybody has to memorize their multiplication facts. I moved from Montessori school to traditional school, and they posted our scores for our timed multiplication facts work on the board. We don't do that. They memorize them when they want to or when they need to. If we notice that their math is taking them longer than they like, then we say, hey, here are some ways that you can get faster at multiplication. And question number 2, how do I think this impacts the math anxiety? I can tell you, most students I know who've gone through Montessori, like, we just know that math is fine because it always has been. And so we don't have the math dread. It's not maybe that we're great at math in terms of, like, I obviously am not an engineer, but I still have always felt like I could be fine in math because I always was. Now, I learned the process as I was going along, so it makes sense to me. And all the rest of the students I've seen learn the process, it makes sense to them. If math is something that comes really easy for them, we can also use materials to give them more, to give them more experiences with math. Any other questions? That last one was a big one. All right, thanks for joining me, Heather. I'm so happy someone did. And I hope you enjoyed the videos. The students were actually really excited to make them.
This was awesome to see inside the classrooms.
I know
Thanks for making the
time. It was every classroom too.
Awesome. That's fantastic. Yeah, I just love learning about this. I appreciate it.
Oh, good. Good. It's so much fun to teach. And look for things coming home next week because it is Montessori Education Week. So it's our week to teach about Montessori. We're looking forward to it.
Fantastic. Thank you so much, Cheryl.
Thank you. See you tomorrow. Bye.